Okay, this little video is for my 1307 students, and it relates to chapter 15, and it relates to naming amines, and I'm going to concentrate just right now on naming simple amines. I know that naming amines is a little confusing, and there's many different ways to name them. So I have recommended that simple amines, you name them simply. So which ones are those? Well, any that have just methyls, ethyls, propyls, or isopropyl groups on them. Oh, I misspelled that. Isopropyl groups on them. I think that would be it. Now keep in mind that amines are organic derivatives of ammonia. Okay, ammonia is NH3. It's a nitrogen with 3 hydrogens on it. So when we say organic derivatives of ammonia, we're basically saying removing one hydrogen and replacing it with one of these substituents converts it into an amine. So any one of these, you put one of them on there, you put one methyl group on the nitrogen, and you have methyl amine. It's simple as that. If you put 2 methyl groups on there, you've got dimethyl amine. So this was methylamine. And this other one is dimethylamine. And if you were to put 3 methyl groups on the nitrogen, you have trimethylamine. So basically you're just using the name amine to name the compound, and then you are naming whatever the substituent is and how many of them are on there. Now, since the nitrogen has room for 3 substituents on it, if you only name one, the consequence of that is that there has to be 2 hydrogens. So methylamine, you got only named 1 methyl, you need a total of 3 things on the nitrogen, so it's going to have 2 hydrogens. All right, so if we had ethyl, so we have an ethyl group on a nitrogen, and only one of them, you've got ethylamine. If you have 2 ethyl groups on the nitrogen, how many hydrogens need to be there? Well, you need a total of 3 bonds around the nitrogen, so you got to add a hydrogen right there. And you have diethylamine. And then if you had 3 ethyl groups, you have no hydrogens now. All 3 positions have been taken up by organic substituents. You end up with triethylamine. All right? So we could go right down through there, and then you could imagine propylamine, dipropylamine, tripropylamine, isopropylamine, diisopropylamine, triisopropylamine. So just those 4 substituents Each gives rise to 3 different amines, so there's 12 right there. 12 different simple amines. But let's say we had a amine where we had an ethyl group and we had a methyl group, and that's all we had on there. Then it would be ethyl, methyl, amine. I'm naming one ethyl, I'm naming one methyl. There needs to be 3 things around there. And so I put a hydrogen on there and I got ethyl methyl amine. All right, so now I'm just playing with 2 of the substituents, and you can see all different kinds of permutations that you can get in there. Okay, you could have 2 ethyl groups and 1 methyl group. And you've got diethyl methyl amine. All right? You could have 2 methyls and 1 ethyl, etc., etc., etc. So all I'm saying is look at a simple amine. So let me draw an amine. Let me draw an amine right here, nice and big. And we'll put that group on it. We'll put this group on it. And we'll put this group on it. So there's an amine. It is a simple amine. The longest continuous chain of carbons is just 3 carbons long. So we got 3 carbons here on the left, 1 carbon on the right, and 2 carbons underneath it. And so we have, just name them. We've got an ethyl, methyl, propyl, amine. Ethyl, methyl, propyl, amine. I've named 3 substituents. There's no hydrogen on there. The nitrogen, when it is called amine, it's only going to have 3 things around the nitrogen. All right, let's do one more. Let me draw one more and you name it. And I'm not drawing in all the hydrogens on all these carbons. Oh, this is getting complicated. It looks complicated, but it is a simple amine. Just kind of look around the nitrogen and see what is on it. Well, pretty clearly you can see on the right and on the bottom we've got ethyls. So it's a diethyl. On the left, what do we have on the left? Isopropyl. Do all of these have appropriate IUPAC names? Yes. But if I started giving you the IUPAC name of some of these right here, I think you'd quickly see that it is much simpler to give it what I'm calling a simple or common name of the amine. So this is an easy way out for lots of simple amines with ethyls, methyls, propyls, isopropyls. Some organic chemists might even expand it more to some other substituents like butyls, secondary butyls, etc. I'm not doing that. I'm just saying, for the most part, if it's 3 carbons, the substituent on there is 3 carbons or less, it's either an isopropyl, a propyl, an ethyl, or a methyl. If that's all you see around the nitrogen, then give it a simple name. I'm not sure what else to throw at you here. We could try to do one more. I think I've gotten about as complicated as I can get on simple amines. All right, so there's one more. And so what would you name that? Okay, on the right and on the left you have methyls. There's two of them. Propyl is underneath. Amine. All right, some of you are thinking, well, how do these have to be alphabetized? How do I alphabetize them? And you can see I've pretty much been alphabetizing them off of the first letter of the name of the substituent. So isopropyl for the I. But I am not going to grade on whether it's alphabetized correctly or not. What would, to me, would be essential is, did you name the substituent properly, not did you put it in the right order alphabetically. So even if you named this propyl dimethylamine, I would accept that. An organic chemist would unambiguously know what amine you are talking about. And if he wanted to draw the structure of it, he could. All right? So there's just a few minutes on naming simple amines.